Welcome to Coach Eichner's Math. Today we are talking about segments and distance. We're going to start off by reminding ourselves that a line segment is part of a line consisting of two endpoints and all the points in between. So if I draw a segment, it's going to be a straight piece of line. It's going to have two endpoints. In this case, we'll name them A and B, and that would be called segment AB. The notation of a segment we are going to say is segment AB. Now, if I want to know the length from A to B, I won't put a line on top. I will merely put the letters AB, and I would say equals, and I'm going to give you a distance, which is what we're going to be doing today. To measure the length of a segment, you can use a number line to count the distance between the two endpoints. So, looking at example 1, we want to find the distance from -2 to +6. So the best way to do this is make yourself a number line. And you want to try to have points on your number line as you're going through this. Again, I'm using my ruler and I am getting close. It does not have to be exact as you're going through this. But I'm going to go ahead and list this as -2. This would be -1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. And I want to find the distance between -2 and 6. So one way to do this is to count the distance on a number line by saying 1, 2, 3, 4, 5, 6, 7, 8. The distance from -2 to 6 is 8 units. In this case, we're using units because we don't know if we are measuring. In my case, that's half an inch, so it would be 4 inches, or 8 half-inch units. Looking down at example 2, it says find PQ, QR, and PR on the number line shown. So looking, the distance from P to Q would be, there's 1, 2, 3 units, but you must be careful, our units are only a half again. So those 3 units is really 1.5 units. Notice with distance, it's important you always put a unit behind it, whether it's generic units or whether they give you centimeters, inches, feet, some sort of measurement term so that people know what 1.5 you're talking about. In this case, talking from Q to R, going from -1 to 1, -1 to 0, 0 to 1, 1 to 2, and then a half. So I'm going to count that as 1, 2, 3, 4, and a half. So I would say that is 4.5 units. Now, looking from P to R, that takes the entire distance. Well, let's be smart about this. Instead of trying to count it on a number line, I can say from P to Q and Q to R would be the same as the whole thing, which we'll talk about on the back side of this notes page. In this case, 4.5 and 1.5 would end up giving me a total of 6 units. Now, when we're using the distance on a coordinate plane, you can use its length, or you can find its length, using the distance formula. And the distance formula happens to be that distance is the square root of x2 minus x1 squared plus y2 minus y1 squared, which I will show you in just a minute is no different than talking about Pythagorean's theorem and saying that c squared equals a squared plus b squared. But instead of squaring c, we're just going to say c equals the square root of a squared plus b squared. But instead of calling it a squared and b squared, I'm going to say the change in x squared plus the change in y squared. So really your distance is nothing more than an application of Pythagorean's theorem. So let's look at the distance between point 2, -1, and -2, negative 3. We want to find the distance between those 2 points. Now, it's real easy for us to see that there was a change in x. The x direction changed by 4 units to get from negative 2 to positive 2. And my y direction to get from negative 1 to negative 3 changed in the negative 2. So really, when I look at my distance formula, I am saying the change in x squared plus the change in y squared. Well, when I look at it, my change in x was 4, so the distance equals the square root of 4 squared, my change in x, plus negative 2 squared, my change in y. Well, that just ends up being the square root of 16 plus 4, which is the square root of 20. Now, at this point, we need to talk about radicals. The easiest thing to do is leave it in radical form, but we can't leave it as square root of 20 as it is not the simplest form. I can break it down and say 20 factors out to be 4 times 5, or 2 times 2 times 5. Since I have a pair, I'm going to say that the distance is equal to 2 radical 5 units. Again, this is without a calculator, helping you out, as you will need radicals and need to be able to use them later on in the school year. Looking at the next step, we're going to examine the measures of PQ, QR, and PR in example 2. Like I foreshadowed earlier, as we pull this back in, we knew that PQ was 1.5, we knew that QR was 4.5, so we knew that the whole thing was 6 units. So now we're talking about it in terms of this postulate called the segment addition postulate. So we want to examine the measure. Notice that 1.5 and 4.5 equals 6. So we're going to say part plus part equals whole. Anytime I add 2 pieces together, it's going to give me the whole, assuming those 2 pieces make up the whole. That is noted as the segment addition postulate. To me, I don't mind if you don't know what the segment addition postulate name is, but I do expect you to be able to use it, as we're going to do in examples 5 and 6. So looking down below, if B is between A and C, I'm going to put a point B out here, and I'm going to draw a segment AC. Well, I know that B is between them, so AB must be 4, and BC must be 5. Then AC would be that whole distance, which must be 9 units. Again, the assumption here is made that we're using units, we don't know what they are, and it does not matter if I have drawn it to scale, as this is merely a sketch to help me in my pursuit of finding AC. Let's look down at example number 6. If AB equals x, and BC equals x plus 6, and AC equals 24, then find AB and BC. Well, this gets a little bit more complicated. We're still going to say that AC is our segment. We're still going to say that B is in the middle. And we're going to say AB is x and BC is x plus 6. And I know that the whole thing is 24. Now, what they've done here is they've taken our formula of part plus part equals whole, and they're asking us to plug in and solve for x, which is just basic algebra. So as I'm looking at it, part AB plus part BC is going to equal AC. Well, we already know that AC is 24. We know that the distance from A to B, notice no segment on top, is x. And we know that distance from B to C is x plus 6. So doing a little algebra, we say that it is 2x plus 6 equals 24. or 2x equals 18, which means that x equals 9. So, x equals 9, we know that AB equals x, and since AB equals x and x equals 9, we're going to say that AB equals 9 units. That would be the transitive property, is AB equals x and x equals 9. I just remove the x from the middle and say AB equals 9. Following that thought process. The distance from B to C. Well, we know that BC equals x plus 6. Again, x is 9 plus 6 means that my distance from B to C would be 15 units. Thank you for watching this edition of Coach Eichner Math, talking about segments and distances. Have a great day.